Let's see some few examples of the languages and tell me whether it is they are regular or not and context free or not. So coming to this language a power m and this one we have already seen it. Definitely finite automata is not possible. Therefore, why? The reason is you might have to save a and you might have to compare against b's and c's. It is nothing but infinite counting and infinite comparison, right? So this language is definitely not regular language. And is this language context free? Yes, the language is context free, and moreover the language is deterministic context free language. So what is deterministic context free language is, if you can give a deterministic push down automata, then the language is deterministic context free language, right? So this language is definitely deterministic context free language. The reason is we don't have any non-determinism here. On seeing A we are sure to push, on seeing B and C we are sure to pop, right? Therefore the language is deterministic context free language, and so if a language is deterministic context free language, it is context free language as well. Okay, these two. And just to tell you the classification, we have regular languages and we have deterministic context free languages and we have context free languages, set of all context free languages. Okay, if a language has finite automata, then the language is regular. If the language has push down automata which is deterministic, then the language is deterministic context free language. Deterministic push down automata, then the language is deterministic context free language. If the language has a push down automata, either deterministic or non-deterministic, I don't know. If a language has push down automata, then it is if a language has push down automata, then it is context free language. So this is what you should understand. So if a language is deterministic context free language, it is definitely context free language. And the same is true with this. It is not regular, it is deterministic context free language and not and also context free. Same with this. And here also see this is not regular. The reason is A's have to be stored and compared against B's, therefore not regular. But then it is deterministic context free grammar, because context free language, because we know what to do with A's, which means we know that A's have to be pushed and B's have to be popped, C's have to be pushed and D's have to be popped. Therefore this is deterministic context free language as well as context free language. And see this is not regular because we have to save infinite string and then count it. Definitely not regular. And if you see this, A's have to be matched against C's and B's have to be matched against D's, and this is infinite language also. Therefore this is not context free also. By the time you reach C's, B's will be on top of the stack and you cannot match A's. So this is not context free language. Okay, therefore if a language is not context free, it is not even deterministic context free or regular. What about this one? This is not regular because you have to save A's and compare against D's, save B's and compare against C's. But then this is deterministic context free language, definitely deterministic context free language. The reason is, on seeing A's you can push A's, on seeing B's you can push B's, and on seeing C's you can pop B's, which means we know whether to push or pop, and exactly we are not having any non-determinism here. Therefore this language is definitely deterministic context free language and hence context free language also, right? And see this one, a power m, b, c power m, and then b power i, d power k, and the language is infinite. A's have to be compared against C's, therefore not regular, but then it is context free and moreover deterministic context free. Why? A's push, B's don't do anything, C's pop, D's don't do anything. We know exactly whether to push or pop. We don't need any non-determinism. Therefore this one is deterministic context free language and by extension context free language. A power m, b power n such that m is greater than n, which means I have more number of A's compared to B's. If I have any such language, definitely it is not regular because comparison is required, and that is unbounded comparison, which means I have to save all this and then compare against this, not regular. And it is deterministic. How? You are going to push all A's and then you are going to pop A's for every B. So you can do that. And finally, at the end, how are you going to accept this one is, at the end, if you see epsilon, which means if the entire string is over, and if top of the stack is containing a, which means at least one a is extra. Epsilon means all the b's are over. Small a means top of the stack contains one a, which means at least one a is extra. Then you can go to the final state. Therefore, there is deterministic context free. It is a deterministic context free language. The reason is we could construct a deterministic PDA, and so the language is context free also. And a power n b power 2n, we have already seen it, right? So we have already constructed a deterministic context free push down automata. How? Push, for every a you push two b's, and for every b you pop a, right? Therefore the language is deterministic context free language, and by extension context free language. Okay, so we shall see more examples. A power n b power n square, this is definitely not regular, because if you observe this, a power n has to be stored, and then it has to be, this saving has to be unbounded, right? And then we might have to compare against base, so there is a comparison involved which is unbounded. Therefore the language is not regular. Okay, and let's see whether we could do it with push down automata. So a power n we can push onto the stack, but then there is no way for every n square I have to pop up one a. So if b would have been in a AP, if length of b would have been in AP, then I could put a loop in the finite automata, and for this one loop I could pop off one a. That is how we did a power n b power 2n, isn't it? See, if you remember this language a power n b power 2n, how we did it is, we are putting these b's in a loop, and in this loop, for one time we take the loop, we are popping off one a, isn't it? For one time we are popping off one a. That is what we are doing using a power n b power 2n. But I cannot put b power n square in a loop, and I cannot compare or pop off for one loop one a. Therefore it is not possible to give any push down automata, either deterministic or non-deterministic. Therefore the language is not context free language. Then a power n b power 2n, the same thing, right? So it is definitely not regular, because unbounded comparison is required, and then we cannot put b power 2 power n in the loop. The reason is, inside a loop we cannot put 2 power n, right? So if you have a loop, I cannot put any loop with 2 power n as the count of it, right? So since 2 power n is not in AP, this one is not possible with context free languages, and definitely it is not regular language also, right? And then w power r, such that w belongs to a comma b star. It is nothing but set of all even length palindromes. So we have to save w and then compare it against w power r. This example we have seen it. This is an example of non-deterministic context free language, which means the language is not regular, because I cannot save infinite w and compare it against infinite w power r. And this language is not deterministic context free language, because I don't know where this center is. Therefore I cannot know till what part to push and from what part to pop. But then this grammar is context free language, which is non-deterministic context free language, and so context free, right? Next one is ww, right? If you see this language ww, definitely we have to save unbounded w onto the stack. So finite automata it is not possible, so it is not regular. And then if you are looking at this language ww, we have to save w first of all, and then compare it with w. For example, if I have string ab, this has to be accepted. I have to save w, which means I have to save w ab. Now how do you identify that this is w and this is w? You can use non-determinism to guess that one thing is, at every point you could guess whether the center has come or center has not come. That is fine. But then even if you have guessed out the center, how can you compare the first symbol, which means the input symbol, with the bottom of the stack? You can only compare the input with the top of the stack, right? But the problem requires that you have to compare the input symbol with bottom of the stack. But then we cannot see the bottom of the stack, we can only see the top of the stack. Therefore this language is not context free language, because push down automata or stack cannot examine the bottom of the stack. Next one is a power n b power n c power m. but then there is a comparison between n and m. It is not that a power n, b power n you compare, and for c you don't do anything. It is not that language. So first of all, a power n, b power n is there, therefore it is not regular. That is fine. And now let's see whether it is context free or not. So for every a you push a, and for every b you pop a, therefore you can accept a power n, b power n. By the time you reach here, there will be nothing remaining in this stack. All the a's will be emptied and all the b's have already been seen. Now you cannot compare the remaining c's whether they are greater than b's and a's or not. By the time you finish comparing a's and b's, you will not have anything on the stack, or you cannot go back to read the input. So there will be nothing to compare against c's. So for such a language, push down automata is not possible. Maybe you might argue that for every a's I'll push 2 a's, and then for every b I'll pop one a. But using that you cannot compare how many a's are remaining, isn't it? Then you might compare a's and b's, but then you cannot compare how many b's are remaining, right? So nothing works for this. See, your logic is for every a if you push 2 a's, and for every b if you pop it, there can be only one b and there can be 4 a's, isn't it? And then this one will be accepted, right? So definitely that logic does not apply here. So remember that this language is not context free language. There is no symbol. If you want an example, I'll show you. See this, if I have a, b, b, c, this has to be accepted, right? So if your logic is for every a you push 2 a's, and for every b you pop 1 a, and then you compare if c's are greater than a's or not, how does that logic work is, for every a you are pushing 2 a's, which means I'll get 4 a's, and for every b you are popping a's, and then you can compare this one. Fine, this one is accepted, but again a string like this a, b, c will also be accepted. The reason is for every a you are going to push 2 a's, which means 4 a's will be pushed on the stack, and for every b you are going to push 1, and for c you are going to compare a's. This one will be accepted. Therefore that logic doesn't work. So this language is not context free language. See this, a power n, b power n, c power n, d power n. N is less than 10 power 10. So obviously the language is finite, and every finite is regular, and every regular is deterministic context free language, and every deterministic context free language is context free language, right? And now a power n, b power 2n, you can compare this. By the time you are done, there will be nothing to compare against c's. See this, a power n, b power 2n, and then c power 3n. So your logic is you can compare a's against b's by pushing 2 a's for every b, fine. And and then by the time this comparison is over, nothing will remain on the top of the stack. Therefore you cannot compare c with a's. So this is not context free. You might try to argue that for every a, instead of pushing 2 b's, I would like to push 5 a's. Sorry, for every a, instead of pushing 2 a's, in order to match this, I can match these two by pushing 5 a's. How does that logic work is, if I push 5 a's, which means this string has to be accepted, b, b, c, c, c. So your logic is for every a I'll push 5 a's, and for b and c I'll keep on popping 1 a. If that is your logic, then the flaw in that logic is this. Understand this? For every a you will push 5 a's, fine. Then that is going to accept a, b, 1, 2, 3, 4. This will also be accepted, isn't it? If you do that, this will also be accepted, right? So it is nothing but if you push 5 a's, it is as good as a power I, b power j, c power k in such a way that 5i equal to j plus k. That will become the language. So we cannot apply the logic that for every a I'll push 5 a's, and for every b and c I'll keep on popping a's. That doesn't work here. So definitely it is not possible, and it is not context free language. So this language is not context free. If it is not context free, it is not regular, or it is not deterministic. Now this one is x can be anything, y can be anything, x, c, y, such that x comma y belongs to 0 comma 1 star. X can be any regular, any regular expression, y can be any regular expression, and only thing is C should be there. It is nothing but set of all strings containing C as a substring. Okay, this is nothing but set of all strings containing C as a substring, which is definitely regular. Since it is regular, it is deterministic context free language, and since it is deterministic, it is context free language as well. Okay, we shall see more examples. See this, x power r such that x belongs to a comma b star, which means x can be anything, but there is a restriction that length of x is exactly L. So how many strings will be possible? If you count the number of strings, there will be 2 power L strings. So this language is clearly finite, and therefore it is regular, and therefore it is context free language, both deterministic and non-deterministic, right? And what about w and w power r such that w belongs to a comma b star is, we have seen that this only this part w is not context free, therefore adding one more part is not going to make it context free. So definitely since w cannot be recognized by a push down automata, wr will never be recognized by push down automata. So this one is not context free language, and so not deterministic context free as well as not regular. Now a power n, b power 3 power n. Okay, so for a's you can push all a's, but for b's you have to put them in a loop, and that loop should contain 3 power n b's, right? And if you see 3 power n is not in AP, right? So since this is not in AP, for the same reason why 2 power n and n square are not context free, this is also not context free. If it is not context free, then definitely it is not regular, and as well as it is not deterministic context free. Now a power n and b power n such that m is not equal to n. So number of a's and number of b's should not be equal. So what you could do is construct the ordinary push down automata where a power m and b power n both are equal, and then what you do is either a's have to be greater or b's have to be greater, which means at the end if you have reached epsilon, then if a is there in this stack, then you accept it, that is one way. Or if b's are remaining and if you reach z0, which means b's are more, this indicates that b's are more and this indicates that a's are more. You can think of it, okay, you could easily do that. So definitely this is context free language, and moreover it is deterministic context free language. Why? Because we know that a's have to be pushed, and for b's a's have to be popped. We know when to push and when to pop. And this one we have already seen it, a power n m and b power n such that m equal to 2n plus 1. I mean, what you could do is so for every 2 a's you can push 1 a and then leave 1 a, and then for every b you can pop 1 a. I mean, in the reverse order, what you could do is you can put a loop for a's, and for every 2 a's you can push 1 a, and then for b simply for every b you can pop 1 a. This is same, but then for first a you need not push anything, leave it, and for second a you can push, right? And for second a you can push. So if you put like this, for every 2 a's you are pushing 1 a, and moreover you have to push one more extra a. So either you push it in the initial state or you push it here and then you come out. So it can be easily done. Therefore this is definitely context free, and moreover it is deterministic context free language. The reason is I know when to push and when to pop. Okay, and next one is a power I such b power j such that I is not equal to 2j plus 1. So this is also simple. So you know we have already seen for I equal to 2j plus 1, you have to check that when you are when you are popping b's, you have to check whether by the time b's are over whether a's are remaining, or by the time a's are over b's are remaining. That kind of comparison could be done. Therefore this is context free. Moreover it is deterministic context free language, right? So the logic is simple. You generally do it for I equal to 2j plus 1, and at the end either b's should be more or a should be more. That one you could check. How? If b's are more, if a's are more, you are going to see this. If b's are more, you are going to see this, right? And a power n square such as n is greater than or equal to 1. It is also simple, it is straightforward. So we know one thing is this is not regular because the length is not in AP. and moreover this language is not context free language also, because context free languages cannot accept a power n square or anything like that. If it is an AP, then we could put it in the loop and we could accept it. Okay, so let's move on to more examples. See this, a power 2 power n such that n is greater than or equal to 1. Again, the length is not in AP, so whenever length is not in AP, push down automata or finite automata cannot do anything. So this is not context free grammar, context free language, and therefore not regular also. Again, a power n factorial, the same reason, length is not in AP, therefore this cannot be context free language. And a power m, m is prime, same reason, length is not in AP, therefore cannot be context free language. A power k such that k is even. So if k is even, then definitely the length is in AP. So definitely the language is regular first of all, and therefore context free, and even deterministic context free also, right? And a power I, b power j, c power k, that I have to be compared against j's and j's have to be compared against k's. So by the time I finish comparing I and j, everything will be over, right? Which means only the difference will be remaining on the stack. So I cannot do such kind of comparisons. See, you might say that push A and then push B and then you compare C's against B's. But then how can I compare B's against A's? Because remaining B's and remaining A's cannot be compared, right? So this cannot be done with context free. Therefore it is not context free. Push down automata is not possible, and hence it is not regular also. Now a power I, b power j, c power k in such a way that j equal to I plus k. So definitely this is context free, which we have seen. We have already seen examples for that. So it is context free language, and moreover it is deterministic context free language. The reason is, for A's we are going to push A's, and for B's we keep on popping A's, and once all A's are over, we know that we have to push B's. Therefore it is very deterministic. So this is deterministic context free language. Next one is a power I, b power j, c power k, d power l such that I equal to k or j equal to l. So how to do this? Compare A's against C's, or you compare B's against D's. That can be done easily, right? So this is definitely a context free language, and moreover this is non-deterministic context free language. The reason is, you construct one push down automata which compares A's and C's, and you construct one more push down automata which compares B's and D's, and then you apply the union to them. So it is context free, and moreover it is non-deterministic context free. A power I, b power j, c power k, d power l such that I equal to j and j equal to I equal to k and j equal to l, which means I should be equal to k and j should be equal to l. Both of them have to be compared simultaneously. It is nothing but a power m, b power n, c power m, d power n, right? So A's and C's have to be compared, B's and D's have to be compared. So we have already seen that it is not possible. The reason is, I cannot compare C's with A's because B's will be on top of the stack. So this one is not context free language. Next one is a power m, d power l, c power k and d power n, right? So if you see this, it is nothing but any number of A's followed by any number of B's, any number of C's, any number of D's. It is simply regular language. There is no need of counting, comparison or nothing, right? You have to just use the push down or this finite automata and you can accept it. And in fact this is nothing but A star, B star, C star, D star. At least one A will be there and followed by any number of A's, at least one B followed by any number of B's, at least one C followed by any number of C, so on, right? Therefore it is simply a regular language, right? We shall see more examples. Now see this language, a power n, b power 4m. So this is, there is no counting required and there is no comparison required. So moreover this b length is in AP. So you can do it with finite automata and you can do it with finite automata. Therefore it is easily possible to do it with a finite automata. So this language is regular. Since this language is regular, it is also context free. And now a power 3, a power 8, a power 13. So what is the common difference? All A's are in AP, arithmetic progression, and moreover common difference is a power 5. So since it is in AP, you can say that it is regular language, as well as context-free language. The same reason it is in AP, regular language as well as context-free language. Now a power n power n, it is not in AP. So if it is not in AP, it cannot be a regular language, and moreover it cannot be a context-free language also, because even for push-down automata, the underlying algorithm is finite automata only, and we have seen that finite automata can accept only arithmetic progression, not the other sequences. Therefore it is not context-free too. W such that W belong to A comma B star and mod W is greater than or equal to 100. So this means that the string length is at least 100, right? So since the string length is at least 100, we can construct a finite automata which will accept this language. So we have already seen it. This is string length is at least 100. I think if you construct a DFA, you are going to get 101 states for this, right? String length is at least 100. This is regular as well as context-free language. Okay. And next one is W such that W belongs to A comma B comma C such that number of A's in W equal to number of B's in W is equal to number of C's in W. If all the A, B and C's all have to be equal, then the problem is for A's you will push and for B you will pop A, or for B's you push and for A or C you pop. You can either compare A's and B's, or you could either compare B's and C's. You cannot compare 3. The reason is you cannot push and pop like that. So there is no way you could actually solve such a question. So if you have to compare number of A's and number of B's and number of C's, you may not be able to come up with a push down automata which does it. So one more if you want to check whether this is context-free language or not, if you see A power n, B power n, C power n such that n is greater than or equal to 1, this language is a part of this language, isn't it? And we have already seen that for this language we are not able to give push down automata. Definitely for the superset we will not be able to give push down automata. This one we are not able to do, then obviously we cannot do this, right? And next one is W such that W belongs to A comma B and number of A's in W has to be at least 1 greater than number of B's in W. This one can be done easily, right? Compare the number of A's and number of B's. At the end, number of A's have to be at least 1 extra, which means by the time the entire string gets over, A should be on the top of the stack, or by the time I have one more extra A, Z0 should be on top of the stack. So either this one or this one says that number of A's are extra. I mean, you have to check that in which state these have to be applied. So anyway, I am saying that this one is definitely possible. Okay. So this is context-free language. Fine. So these are all the examples of context-free languages. We shall see about grammar and its properties next.